In this video, I will be explaining how to assign R and S absolute configuration to a chiral molecule using the Cahn-Ingold-Prelog priority rules. The absolute configurations R and S stem from Latin words rectus, which means right, and sinister, which means left. I will explain this concept using the following question. Assign the absolute configurations to the molecule below. Before answering this question, we need to recall that this wedge bond means that the NH2 group is coming out of the plane of your screen, pointing toward you. And the dash bond simply means that the hydrogen is pointing away from you toward the back of the plane of your screen. The CH3 or methyl group, as well as the fluoro group, both lie in the plane of your screen. Next, we have to identify the chiral center. The chiral center in this molecule is this carbon, and that's because there are 4 different groups attached to the carbon. The groups are fluoro, methyl, hydrogen, and NH2. Next is to assign priority numbers 1 to 4 to the 4 different groups, with 1 being the highest priority group and 4 being the lowest priority group. To determine which group gets what priority number, we have to first of all list the 4 different groups, starting with the first atom in each group. Let's start with the methyl group. The methyl group has 1 carbon and 3 hydrogen atoms. The NH2 has 1 nitrogen and 2 hydrogen atoms. The fluoro group has just 1 fluorine atom. And lastly, the hydrogen, which is just 1 atom. After listing the groups, compare the first atom in each of the 4 groups. Then assign priority number 1 to the first atom with the highest atomic number, and priority number 2 to the atom with the second highest atomic number, and priority number 3 to the atom with the third highest atomic number, and priority number 4 will go to the atom with the least atomic number. Based on this, priority number 1 will go to the fluoro group. And that's because fluorine has atomic number of 9, which is the highest compared to the other atoms here. Priority number 2 will go to the NH2, and that's because the nitrogen in the NH2 has atomic number of 7, which is the second highest atomic number here. Priority number 3 will go to the methyl group, and that's because the carbon in the methyl group has an atomic number of 6. And lastly, priority number 4 will go to the hydrogen, and that's because hydrogen has the least atomic number, which is 1. Next, redraw the structure, replacing all the 4 different groups with their respective priority numbers. Then rotate the molecule such that group 4 will be in the back of the chiral carbon. However, since group 4 is already in the back of the chiral carbon, there is no need to rotate this molecule. Then draw an arrow connecting groups 1, 2, and 3, ignoring group 4. The absolute configuration of this molecule will depend on the direction of the arrow. For example, if the arrow goes in the same direction as your clock at home, we will assign an R absolute configuration. But if the arrow goes in the counterclockwise direction, we will assign an S absolute configuration. In the case of our structure, since the arrow goes in a counterclockwise direction, absolute configuration of this compound is going to be S. In some molecules, group 4 may not already be in the back of the chiral carbon. If that's the case, how then can we rotate the molecule such that group 4 would be placed in the back of the chiral carbon? Let's explore different scenarios where group 4 is not already in the back of the chiral carbon. In this example, group 4 is on your right-hand side. The question then becomes, how can we rotate this molecule such that group 4 will be positioned in the back of the chiral carbon? Many students find it difficult rotating the molecule using only their imagination. If you're one of such students, there is another approach you can explore. You should start by asking yourself the question, which position can I view this carbon from that will place group 4 in the back of the chiral carbon? Viewing the carbon from the left-hand side will place group 4 in the back of the chiral carbon. Now, group 3 will be to your right, group 2 will be to your left, and group 1 will point upward. Redraw this structure such that group 3 will be placed to your right, and group 2 to your left, and group 1 pointing up. Then draw an arrow connecting groups 1, 2, and 3, which will result in a counterclockwise direction, giving you an S-absolute configuration. Here's another example. But in this case, group 4 is on your left-hand side. The question then becomes, which position can I view this carbon from that will place group 4 in the back of the chiral carbon? Viewing the carbon from the right will position group 4 in the back of the chiral carbon. Now, group 2 will be to your right, group 3 to your left, and group 1 will point upwards. Redraw these structures by placing group 2 to your right, and group 3 to your left, and group 1 pointing up. Then draw an arrow connecting groups 1, 2, and 3, resulting in a clockwise direction, giving you an absolute configuration of R. Here is another example, but in this case, group 4 is pointing upward. The question you should ask yourself is, which position can I view this carbon from that will position group 4 in the back of this carbon? Viewing this carbon from the bottom will position group 4 in the back of the chiral carbon. Now group 2 will be to your right, group 3 to your left, and group 1 pointing downward. Redraw this structure by placing group 2 to your right and group 3 to your left, while group 1 is pointing to the bottom. Then draw an arrow connecting groups 1, 2, and 3, which will result in a counterclockwise direction, giving you an S-absolute configuration. Here is another example, but in this case, group 4 is placed on a wedge bond. The question you should ask yourself is, which position can I view this chiral carbon from that will place group 4 in the back of the chiral carbon? You actually have to go around your screen and view this chiral carbon from behind your screen. Now, viewing the carbon from behind your screen will place group 4 in the back of the chiral carbon. Now, group 1 will be to your right, group 2 will be to your left, and group 3 will point upward. You should then redraw this structure by placing group 1 to your right and group 2 to your left and group 3 pointing up. Then draw an arrow connecting groups 1, 2, and 3, which will result in a clockwise direction, giving you an R absolute configuration. There is another method to determine the absolute configuration when group 4 is placed on a wedge bond. Simply ignore group 4 and draw an arrow connecting groups 1, 2, and 3. This will result in a counterclockwise direction, giving you an S absolute configuration. Inverting this configuration will give an R as the absolute configuration for this molecule. This is where I will draw the curtain for today's video. Thank you.